Okay, so now we want to take that information that we've come up with, the four trig addition formulas, and use it to come up with even more information. We can use these as our basic fundamental building blocks, and the result is that we should be able to get more formulas that will help increase the number of substitutions we can make when we solve. So we're going to start by taking these four formulas that you see here on the left and using them to derive a formula for tan of x plus y. Now we know from our previous identities that the tangent of any angle is the sine of the angle over the cosine of the angle. Now in this case, x plus y just represents some specific angle measure. So tan of x plus y will be sine of x plus y over cosine of x plus y. And each one of those has its own substitution that we can now make. So we will be able to say, well, this is going to be sine x cosine y plus cosine x sine y. And the whole thing will be divided by cosine x cosine y minus sine x sine y. And now we're kind of stuck, because we have a lot. We now have eight terms. Okay, well, not really 8 terms. We have 8 different small trig equations multiplied together, added or subtracted, whatever you want to call it. And what we really want is something simpler. We want something simpler that's a little bit easier to know. And it would be nice if it was in terms of tangent, or fewer functions than we had right now. Tangent would be the best option. In order to do that, we just simply need to rearrange, okay, to change the expression on the right-hand side. When we do that, to change an expression on one side of an equation, we're really limited to multiplying through by a factor of 1. Alright, so let's actually do that. Let's multiply through by a factor of 1. But the question is, which factor of 1? Right? What should I multiply through by? Well, we're going to multiply each side by 1 over cosine x cosine y. It will become apparent in a second why this is a useful simplification of the expression that we've started with. Take a look at what happens on the bottom. On the bottom, the very first term, the cosine x cosine y, becomes 1 minus sine x sine y over cosine x cosine y, which can reduce to tan x tan y. Now it's a nice simple bottom, much easier than we had before. In the numerator, notice that for each term in the numerator, there is either a cosine x or a cosine y in that term. Therefore, when I multiply by 1 over cosine x cosine y, those terms will reduce to 1, and I'll be left, as it turns out, with a ratio of sine over the remaining cosine in the correct angle. Meaning that for the first term, I'll have sine x over cosine x, which just becomes tan x. And for the second term, I'll have sine y over cosine y, which just becomes tan y. Thereby giving us the formula that tan of x plus y equals tan x plus tan y over 1 minus tan x tan y. Let's go down for 1 second and just take a look at this list. This is our sum and difference formula list. So these 6 formulas represent our sum and difference formula list. And you can see that sine of alpha plus or minus beta, we've condensed them down into easier ways to write them. So notice that the plus or minus in this first equation matches the plus or minus on the right-hand side. But when we go down one equation, the plus or minus on the left-hand side is opposite the plus or minus on the right-hand side. Well, if you've never seen the minus with the plus underneath it, that's just simply saying minus then plus. Meaning that if I have cosine of alpha plus beta, the right-hand side is going to be cosine alpha, cosine beta, minus, etc., what comes after. It's just telling us which one corresponds to the sign on the left, so they should be opposite. Right? So this list of 6 then becomes an even bigger foundation, an even larger list of identities that we can use to solve more things. Okay? So let's then look at what next. What else? What else can I know more about? Let's use that information then to derive a formula for sine 2x. And this is really talking about sine of twice 2 times the angle measure. It is tempting for many students to say, well, if I want to know what sine of 2 times pi over 3 is, right, then it's just 2 times sine pi over 3. And we see the 2, we just multiply the value by 2. Well, we should know better. Right? We should know that, in fact, sine 2 pi over 3 is equal to sine pi over 3, which is equal to root 3 over 2. And if we go one more down, 2 times sine pi over 3 actually gives us a value greater than 1. Right? So both those just little numerical ideas tell us that this simply cannot be the case. Right? It is not the case that sine of 2 times an angle is just simply 2 times the side ratio. That's not going to work for us. So we need a formula. It's actually an easy formula to come up with because of the information we just derived. Simply because sine of 2x can be rewritten as the sum of sine of the angle x plus the angle x. So we're left then with, when I apply the trig addition formula that we just developed, sine x cosine x plus sine x cosine x, and we're left with 2 sine x cosine x as our expression. And there's another identity. Very easy to start building up a lot of formulas off of those simple trig addition formulas that we were looking at. We will have a larger number of these identities to work with. We won't derive each one. Some of those will be your homework tonight. But for now, right, I will add the list of these identities to your Google Docs and go ahead and look at that identity list. Some of them you'll derive from homework tonight. Some of them you'll just need to look at and know that they are identities to use in the future.